So the Delta team was tasked with building a distributed real-time virtual reality game, Bumper Cars to be precise. That's quite a mouthful. So how did we actually go about building this game? Well, we had the Oculus Rift, and this is basically a 3D headset that allows you to track the user's head orientation as well as other parameters. And it allows you to really immerse a user in a 3D game. So using that as a basis, how do we actually go about building with this platform? So this is a screenshot of the game. Now, we decided to write this in C++. So that was our starting point. We could have used an engine such as Unity or Unreal. We decided instead we wanted to start off and go from the very scratch level to build it ourselves, get all the technical depth, and really get to grips with the project. So up on the screen here, we have the left and right eye views. You're currently seeing a player, and this is all rendered using OpenGL. So again, built from the ground up here. Texturing is done on a Minecraft-style voxel world, so it's using the same algorithms Minecraft uses to build its terrain. And you're currently seeing another player whose head will follow the head as the head moves around. So that's the graphics side. Let's move on to the server side. So this is the physics engine now. So this is implemented using boxes surrounding all of our objects, including the terrain system. And when objects collide with each other, the physics system detects this. Now, as you can imagine, there are lots of corner cases, and it's quite a tricky thing to implement. But in the end, we managed to get it working just about. So that's the physics system. And this is on the server side. And this is our server. Not quite as interesting as the graphics side. But what this does effectively is takes all of the client input, transfers it across the network to the server, and then the server's running multiple threads. So you've got a thread for the physics, thread for updates, and also threads for handling, sending back to the users. And this is effectively taking user input, running the ticks, calculating, and firing it back. And it's all done over UDP, over TCP, for reasons those of you who've done the networking course will fully appreciate. So that's what we've got so far. There's a lot we'd like to add. The main thing is client-side prediction. At the moment, everything's on the server side. You're running in lockstep. So if you miss an update packet from the server, you get jitter. If you run it over an open network or a WAN, you're going to struggle. You're going to get lost packets. It's not going to be smooth. So the next step, client-side physics. After that, working sound. You bump into other cars, you get a rebound. There's no sound effect. What we want to do, 3D sound. That's the next step. And finally, network optimization. I've mentioned we've got a problem with open networks. We really want to get this sorted. So the next step will be to try and make a sort of optimized set for UDP. So apps and so forth for that. I need to hurry up, I understand. Right. So what we want to do is dependencies. So we may need to manage our dependencies within the team better. There were times when we as developers struggled to get stuff coordinated well, and that's something that we've understood that next time we really need to get keyed up on. Second thing is decoupling. Physics and graphics were tightly coupled from the start. Testing that was interesting, as I'm sure some of you can appreciate. So we've learned that we need to really separate our stuff into modules and really test from the ground up. And the final thing is integration. We spent a lot of time integrating our components together, and we really could have streamlined that more. Documenting APIs would have been probably a key factor to help with that. So documentation is not